Hello, my name is Mr. Asprey and this is my Edexcel IGCSE Maths 2026 Predicted Practice Paper 2. Massive disclaimer, as always, nobody knows what's going to be on Paper 2. Edexcel can ask any questions they like. This is not a guarantee that these topics are going to come up. What I've done is I have picked what I believe to be the 30 highest value topics that did not come up on Paper 1H, and I've put together a question for each of those topics. So 30 questions, I've made it challenging, and I've also picked questions which hopefully you will find to be fresh because some of them I've made myself, some of them I've used different specifications, but ultimately they are in order to test your understanding of these important topics and expose any gaps that you may have, so it's going to help you with your revision. What I would like you to do is make sure that you try the paper yourself first before watching the solutions. So you can go to my Google Drive and you can download this paper, have a go yourself, and then come back and watch the solutions and all the tips and tricks that I give along the way. And then if you would like more content because you found this very helpful, then I would recommend checking out my live revision session because I have compiled 2 more predicted practice paper 2Hs, and I'm going to be going through those live in the session on the 31st of May. And in the session you can ask me questions as we go along. It's 3 hours. Anyway, if you are interested, the link is in the description, and I'll talk about it more in detail at the end of the video. But just a quick one, if you are interested, I would recommend grabbing a ticket as soon as possible because last year this session did sell out. Okay, that's all from me now. Hope you enjoy the paper. Let's get into the maths. Let's boost those grades. Come on. Okay, let's do it. 3 hours, 30 questions, 140 marks. Subscribe. Yes, that's a good idea. Okay, A and B are numbers such that A is equal to blah, 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 and B is equal to blah, blah, blah. Find the highest common factor. Okay, so what we can do for any highest common factor questions is we could draw a Venn diagram, like so. Okay, that will do. We put A here, put B here, and we think, well, what ones do they have in common? Well, they have 3 squared, which means I could put 3 in the middle twice. And A has 3 to the 4, so there's an extra 3 and an extra 3 there. It also has 2 squared, which B doesn't have, so it goes over there. And then 7, well, they share 1 7, so we put that in the middle. And then B has an extra 7, because it's 7 to the power 2. Okay, so the highest common factor is equal to everything inside the middle. So it's 3 times 3 times 7. Which we could write as 3 squared times 7, which is also the same as 9 times 7, which is 63. So we could leave it like that, or like that, either is fine. Okay, let's box that up, and let's move on. So now it's asking us to find the lowest common multiple of A and B. Well, if we've got this Venn diagram set up nicely, then the lowest common multiple is all of the numbers inside the Venn diagram times together. So there are 2 2's inside the total Venn diagram, and there are 4 3's, and there are 2 7's. Perfect. Now, I'd probably leave it like this, but just in case you haven't and you'd like to know what the correct answer is, we can put it in our calculator. Like so, 3 to the 4, and then we're going to multiply that by 7 to the power 2, and we're going to get that. So either I think would be correct, whether you write it as a whole number like this or indice powers. Perfect. Okay, we've got 14 students in Class A, and the mean mark in Class A is 58, and there are 16 students in Class B. The mean mark of all 30 students is 61.2, and find the mean mark of Class B. Okay, so what we know is if we wanted to work out the mean, then it would be the total number of marks divided by the number of students. So that's how we work out the average. We add them all up, divide by the number of data points, or in this case, number of students. So if we look at A, Class A, so the mean is 58. The total number of marks we don't know. We don't know what the total of A is. But we do know the number of students, which is 14. So we can rearrange this and we can work out the total number in A by doing 58 times by 14, which equals 58 times 14 is 812. Okay, great. Now we can look at all of the students as a whole. So I can say A and B all together. So A and B all together, the mean is 61.2, and that's going to equal the total of A and B together divided by the total number of students in A and B, which is 14 plus 16. Okay, so therefore the total number of marks in A and B will be 61.2 times by 14 plus 16, which makes 30. Okay, so we could do 61.2 and times it by 30, and we get this. Okay, right, now we can look at B, and the total number of people, or number of marks, sorry, in B is going to equal the total in A and B minus the total of A. Just take away all the people in A from the overall total, and that's going to give us the total of B. So we take away 812, and we get this. Okay, and then the mean, of course, is equal to the total, whoops, wrong way around, the total divided by the number of students, which is 16, is it? Yeah, 16. So we divide that by 16, and we get 64. That's our final answer. Nice little question, that. Okay, we've got frequency table, and yeah, I can just see a frequency table. I can see that it says work out the mean. So let's do it. Let's work out the mean. So we're going to take the midpoints, because that is the that's the average temperature for each of these classes. So we're just going to go in the middle of each, and then we're going to times it by how many times that has happened, which is the frequency. So we can times, here we go, that's 25. Okay, and then we can do 17.5 times by 8, which gives us 140. And then we can do 22.5 times by 13. And I think it's good to do this because then all these numbers are going to go towards your method marks. So just in case you do make a slip, then hopefully you can be rewarded just one less than the actual total number of marks. Okay, so yeah, this is what I would do. And then I'll just times that by 6, and we get 195. Okay, so the mean is, we add these all up, like so. So I'll just write them out here, add it up. Again, just showing the examiner I know what I'm doing. And then we divide it all by the number, or the total frequency. Now a lot of people just divide it by 5, which is completely wrong because there are 5 classes. It's not that, it's the total frequency. And the total frequency is 2 plus 8 plus 13 plus 21 plus 6. Most of the time it's given in the question, like it is there, it's 50. Okay, great. So I can just do a fraction sign, add all of these numbers up. Like so, and then divide it all by 50. Okay, great. It doesn't ask me to round the mean, so getting a nice clean number like that gives me confidence that that is right. Okay, great. Degrees Celsius if I'm being fancy, but yeah, you should put the units on. Good practice. Okay, great. Okay, the next part, CJA says that the median temperature is 22.5 because 22.5 is the middle number in the middle group. Is she correct? Give your reasons for your answer. Well, no. she's not correct, and that's because the median depends on the frequency and how it's distributed. So the median would be in the kind of 25th position because there are 50. And the 25th position, well, there's 2 and 8, that makes 10. And then there's 23 if I'm adding them up. So therefore the 25th would be in this class anyway. So no, and you can say as the 25th data point, what are these data points? Are they people? Weather, temperatures, yeah. As the 25th temperature is in the 25 to 30 class. Also, another reason why, the exact median can't be found in a group data. The exact median cannot be found when using group data. And that's why we always say things using group data as in like use an estimate for the mean. So we wouldn't say find the exact mean or median. So there we go. Okay, I've got a ratio question here, and it looks like it's going to be one of those combined ratio questions. So it says that we've got white shapes and black shapes, and some of them are circles, some of them are squares. Now the first thing is that the ratio of white shapes to black shapes is 3 to 7. And the ratio of white circles to white squares is 4 to 5. And the ratio of black circles to black squares is 2 to 5. Okay. Now what I'd really like, because it's asking us to work out the fraction of the shapes that are circles, I would love to be able to have a ratio which included all of these 4 things, like so. So a combined ratio of all 4 of these. Now, in order to put those together, I'm going to need to use the total white and black and kind of slot that into there and slot the this one into here. Now that one actually works perfectly because the number of black pieces has a ratio of 7 parts, and the circles to squares of black pieces is 2 to 7. I could just slot that straight in because that adds up to 7 parts. But it's not the case for this because that adds up to 9. But what we can do is we can multiply this ratio here by 3. Because then, if I multiply it by 3, and obviously I have to do it to both, then that is now 9 parts, which I can then use to split the white pieces up into circles and squares because they add up to 9 as well. Okay, so I've got this 9 to 21, which means I can say that I want here 9 and I want on this side 21. And of those 9, I can split it up 4 to 5 from circles and squares. And then of this 21, I can split up the black pieces. Well, I need this to add up to 21. At the moment it adds up to 7, so if I times it by 3, then now that ratio adds up to 21. So I can use this 6 to 15 like that, and that is going to be perfect. Okay, so now I can compare all of these and I can look at the total number of circles. So the circles has 4 and 6 parts because you've got you've got white circles and black circles, 4 and 6, and then the total, so looking at the circles as fractions of the total amount, and the total amount will be 4 plus 5 plus 6 plus 15. So the fraction of circles, I should say, the fraction of circles is going to be 10 over, add those up, 30, which is equal to 1 over 3. Perfect. Okay, compound interest, and we have a total of this amount of money, and we are going to be using 3.5% interest. So to work out the interest multiplier, you can always start with 100, add on because you are getting interest, which means that it's a positive thing. So you're adding on extra money, 3.5, then divide it by 100, and that gives you the percentage multiplier. So we can do 100 plus 3.5, and then do that equals, and then divide that all by 100, and that is the multiplier, so 1.035. And because this is happening multiple times, we do the interest, the multiplier, to the power of the number of years. Be careful, it's not the whole thing, because that will give you loads of money. It's just the multiplier that we raise to that power. Okay? So let's take the 2,400, let's multiply it by this, and then let's raise it to the power of 3, and we get this. And I've actually made this question myself, because this I know is going to catch students out. It says work out the interest earned, not the overall money that is in the account now, but the interest. So the interest is the new amount minus the starting amount. Okay, so we need to subtract this, and it says to the nearest penny, so that would be 260.92. So that would be our final answer. So just, make sure you read the question. Okay, Kate was asked to factorise this in that form. Kate says that the sum of A and B must be 6 and the product must be 5. Explain what is wrong with Kate's statement. Well, simply put, the sum of A and B must be 5, so it's the other way around. It's the number of x's, that's what they must have summed to, and the product of A and B must be 6. Yeah, she's got it the wrong way around. Okay, now we are factorising, and a bit of a tricky one, but again, the reason why I chose this question is because it says factorise fully. Now, a lot of students make a mistake here. They'll realise that both two terms have a 2, so they'll take out a 2, like so. But when it says fully, it means that there's going to be multiple ways that we could do this. So there's going to be an additional step that you'll need to do, and that is to notice that m squared minus 1 is the difference of two squares, because the difference of two squares says that when we have a squared minus b squared, it's equal to a plus b multiplied by a minus b, and both these two terms are squares, and there's a minus in between, so it's difference of two squares. So it becomes m plus 1, m minus 1. Now you can put the two brackets either way round, doesn't make a difference, but yeah, that is going to be our final answer. Equations. We've got fractional equations here. There's multiple ways of doing this question. You could multiply through by the kind of common denominator, which is 12, or you could create a common denominator, which is probably what I'm going to do here. So I'm going to multiply the top and bottom here by 3. So that will give me 9x minus 6 over 12 times top and bottom of this fraction by 4. So that will give me 8x plus 20 over 12. and we're going to times top and bottom here by 2, which gives me 2 minus 2x over 12. Okay, great. So now I can just multiply through the whole equation, every term by 12, which will get rid of the denominators. Now I'm going to put these in brackets because the most common mistake is that students forget to apply the negative to both terms in the in this fraction, essentially. So once the 12 has been cleared, it's very common to see students do minus 8x and then have plus 20, but of course that negative needs to be distributed to that 20 as well. So that's why I'm putting it in brackets so it's clearer to see. Okay, great. So when we multiply this out, we're going to get 9x minus 6, we're going to get minus 8x, and we're going to get minus 20. Once again, reiterating that common mistake. So let's collect up the x's on this side. You've got 9x minus 8x is 1x. We've got minus 6 minus 20, which is minus 26. And then on this side, we've got as is. We're going to add 2x to both sides, which gives us 3x on the left-hand side and cancels the minus 2x on the right. We're then going to add 26 to both sides, which gives 28 on the right when we add the 26 to the 2, and it cancels the minus 26 on the left. And then we're going to divide through by 3, and we're just going to leave our answer like that. No need to write it as a decimal or any like recurring decimals. Let's just leave it nice and neatly as a improper fraction. Okay, we've got inequalities on graphs, and we've got two straight lines here, and the region is clearly bounded by, in fact, 3 inequalities that we need to give. Okay, so the way that I do these questions, I tell my students to, is to make sure that the line is written so that it's y equals. So we just need to rearrange this this equation. So we're going to add x to both sides. So that will give me x plus 2, like so. Okay, so now it's in this form, we ask ourselves, is the region below the line or above the line? Well, you can see the line here. Clearly, the region is directly below that line. So that means we just use a less than sign, or less than or equal to, should I say, because it is not a dotted line. It's a solid line, so we use a less than or equal to. So the first one will be y is less than or equal to x plus 2. Okay, so the next line here, this one that comes down like this, I'm going to rearrange it again, so it's y equals minus 3x, because I'm subtracting 3x from both sides, plus 15, because I just want it to be y equals. Now once I've done that, I've asked myself the question, is the region above or below this line? Well, you can see that I have to go upwards from that line to get into the region, so it's above, which means I use a greater than or equal to sign. So we say y is greater than or equal to minus 3x plus 15. Okay, and then the final line is clearly the x-axis, which is the line y equals 0. And once again, I've got it as y equals, perfect. So is the region above or below? Well, clearly it's above the line. So we're going to say that y is greater than or equal to 0. Now, there was an indice question on paper 1, but I thought I'd throw another indice question in because indice is what I believe to be the highest value topic, and I think it's good to just keep practicing, and it's just a very important topic. Okay, so the trick here for these types of questions is to spot that all of these numbers are in fact powers of 2. And in fact we could write them all out as the power of 2 that they are. But first, because all of the terms at the top are multiplied and here that they're multiplied as well at the bottom, we could do some simple cancelling. So I could divide through by 8, which cancels that factor of 8 and makes that 2, because 16 divided by 8 is 2. Okay, so now we can write it as 2 times Now the square root of 32. Well, 32 is equal to 2 to the 5, because it's 2 times 2 times 2 times 2 times 2. So I can write that as 2 to the 5, and then when we square root, that means that we are doing to the power of a half, because the square root is the power of a half. And then we are raising that to the power of 2n plus 4. Okay, great. And that's equal to 2 to the x once we've divided it all by 4, which is 2 to the 2. And then that needs to be raised to n plus 3. Also, just 2 on its own is 2 to the 1. So it's just helpful to put all the powers on like that. Okay, now this is a power tower. And when we have a power tower like this, we just multiply along. So this is 2 to the 1 times by, now multiplying these, a half times 2n plus 4 is just simply n plus 2. So if you just half 2n plus 4, you get n plus 2. Okay, so let's just do that one step at a time. Like so, and actually let's expand out this power tower here. So you're just timesing by 2, so it's 2n plus 6. Okay, great. Now let's expand this power tower here, and you're timesing by 5, so it's 5n plus 10. Okay, great. And then when you multiply 2's, then you add the powers. So adding these powers gives us 5n plus 10 plus 1, so 5n plus 11. Great. And then when you're dividing 2's, which we can do now because there's just 2 on the top and 2 on the bottom, and means we subtract the powers. So 5n minus 2n is 3n, and 11 minus 6 is 5. Great, now we've got 2's on both sides, therefore their powers must equal, so we can say that x is equal to 3n plus 5 for our final answer. Love that. Okay, angles in polygons. Now the most important formula, I believe, that you need to remember is that the sum of the interior angles of a polygon is equal to n minus 2, the number of sides, minus 2, times by 180. Sorry. That's important. Definitely memorize that. And this is going to be very helpful because we have a 7-sided shape and we also have an 11-sided regular polygon. So if we look at the 11-sider first, well, we would do 11 minus 2 times by 180, and that will give us the total sum of all of the angles. So 11 minus 2 is 9, times by 180 is equal to this. So therefore, one angle, let's call them y, because these will all be those will all be the interior angles of that 11-sided shape, and because it's regular, they're all going to be the same. So y is equal to this divided by 11. So we're going to divide that by 11, and that's not going to give me a pretty number, but it does say 3 significant figures here, so I know that I'm going to be doing some rounding. So let's just leave it like that. In fact, being fancy, we can even put a little approximation sign in there. Very nice. Okay, so now if we look at just the 7-sided shape, which is the shaded shape, it has 1, 2, 3, 4, 5, 6, 7 sides, then we could do 7 minus 2 times by 180. So even though it's not a regular shape, this formula still just tells you the amount of angle in there. Now I've got a feeling I'm going to be using this number again, so I'm going to press store to A, so that number becomes A. And then I'm going to do 7 minus 2, I think I can do that in my head, that's 5, yeah, times by 180 is 900. Okay, so inside that shape then, there's 900 degrees, and there's also, that's also the same as 2x's plus how many y's are there? 5. Okay, great. So that means that 2x will equal 900 minus 5y. So x will equal 900 minus 5y divided by 2. So on my calculator, I could do 900 minus 5 times y, which we know is that 147.3. But I'm going to use the exact value, which I saved as a, and then we're going to divide that by 2. Great, so we get 81.8 to 3 significant figures. So that's going to be our answer. Perfect. Volume and surface area. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. Okay, great. And then Janet says that the volume of the cube is equal to the volume of the cuboid. Is Janet correct? Well, let's find out. Okay, so we can work out the surface area of the cuboid. There's going to be 3 faces, well 6 faces, but they'll come in pairs. So face number 1 is going to be 6 times 8. That's face number 1. And face number 2 is going to be, let's call it this side over here, so that's 18 by 6, so 6 times 18. And face number 3 is the base or the top, which will be 8 along by 18. So that'll be 8 by 18. Okay, great. So surface area of the cuboid is going to be all of these 3 things. So that's 48. That's 108, and oof, testing me now. That is 130. No, 144. Okay, great. So what we do now is we add these up. Yeah, so we can add these up, and then that gives us 300. Great. And then we need to multiply that by 2 to get 600. Now, why do we multiply it by 2? Well, as you can see, a cuboid has 6 faces, and they come in pairs. So face number 1, which was the front, is exactly the same as the face at the back. And face number 2, which is the right-hand side, is the same as the left-hand side. And face number 3, which is the top, is the same as the base. So we can add them up and then times them by 2. Okay, so that means that the surface area of the cube is equal to 600. Now, if the cube has dimensions x, then they're all the same, because cube is it's a platonic solid, which means that it has is created by regular shapes, so they're squares. We all know what a cube is. Why am I trying to explain this? It means that each face is x squared, and there are 6 of them. So 6x squared is equal to 600. So x squared is equal to 100, so x is equal to 10. Okay, great. So the volume of the cube is equal to x cubed, because you do length times width times height. So it's 10 times 10 times 10, which is 1,000. And the volume of the cuboid, again, we can work this out because it's a prism, it's length times width times height. So you just work out a cross section, which will be length times width, and then times it by, in this case, like how far back it goes. So we just multiply the 3 dimensions together, basically. So it's 6 times 8 times 10, times 18, sorry. So 6 times 8 times 18 is equal to this. These are all centimetres cubed. And we must conclude as well, so we can say Janet is incorrect as volumes are not equal. Cumulative frequency, easiest 1 mark you'll get on the IGCSE paper, just adding up the numbers as you go along. So 5 plus 10 is 15, so we have 5 and then we have 15, and then we add on 20, which is 35. Then the next group has, the next group has another 20, so 55. Not sure why I'm using my calculator here. Add 15 gives us 70, and then add 10 gives us 80. And easiest 1 mark, because you can even check your answer as well, because at the top it will always tell you what the total frequency is, so that should be the answer at the end there. So yeah, pretty confident got that right. Now on the grid opposite, we need to draw this, this completed table. So the key point to remember is that we always plot the end points like so, with the cumulative frequency. So 250 is 5, 300 is 15. So 250 is 5, 300 is 15. Then 350 was 35, and then 400 was 55, and then 450 was 70, and then 500 was 80, I believe. Yeah, perfect. Okay, great. So it ends up at 500. So the 550 there is a bit of a red herring. And then we're going to just connect up the cumulative frequency graph like that. So we're just going to start here and here. I'm going to always use straight lines. You can use a smooth curve if you want, but I would recommend just using straight lines. Less chance of making a mistake, and yeah, and the examiners like it. Okay, great. So there we go. That's my cumulative frequency graph. And then it says WAN says 60% of this group of people have a weekly wage of 360 or less. So 2 ways of doing this. You could either go across at 60% of the total frequency, or you can go up from 360. I'm probably going to go up from 360, because then I don't have to do a calculation and find out what 60% is. So 360, well, there are 50 pounds in between here and here. So divide 50 by the 10 little boxes is 5. I need an extra 10 to get to 360, so I need 2 boxes. So I'm going to go up right here. I'm going to draw my line nice and straight, and then I'm going to go across as best I can, like so. And that to me looks like a frequency of 38. So 360 or less would be 38 people, because yeah, 38. 360 or less means you're going down, so that's 38 people. 360 or less is 38 people out of a total 80, which as a percentage is 47, because we're going to multiply that by 100 to make it as a percentage. So that would be 47.5%. So we're going to say that WAN is incorrect. And yeah, we've shown the reason why. So so that will do. Okay, we're sketching graphs. So I'm always going to go into my table function on my calculator to do this. And we're going to go x squared minus 3 x and then plus 1. We don't need a second function. We want to start at minus 1, we want to end at 5, and we want to go up in steps of 1. So minus 1 is 5, 0 is 1, 2 is minus 1, and then scroll down to find 5. That's 11. Great. Now we need to connect them up and form a smooth curve. So minus 1 is 5. And then 0 is 1. 1 is minus 1. And 2 is minus 1. 3 is 1. And 4 is 5. And then 5 is 11. Now, they always do this. They leave the opportunity for you to connect it up with a straight line at the bottom, which will not be correct. Okay, there must be a clear minimum point on a quadratic. So I'm going to come in a nice smoothest curve as I possibly can, come down like that, and then I must show that there's going to be a minimum point. So I can almost like put a little minimum point coordinate in there, like so, and then come up the other side like that. Okay, and that's pretty good. I'm pretty happy with that. Maybe just slightly make it a bit better down the bottom. It's really hard to do it on a computer, but yeah, I'm pretty happy with that. There we go. It's nice and clearly defined quadratic. Okay, great. And then it says by drawing, and this is a classic question. I know students really dislike this question, so that's why I put it in. By drawing a suitable straight line on your grid, find estimates to one decimal place to the solution of this equation. Okay, so what I'm going to do then is I'm going to just remind ourselves nice and clearly what the graph that I had drawn. So I have drawn y equals x squared minus 3x plus 1. That is drawn right here. Okay, and we need to use that graph. Okay, that's the one that's drawn on a purple. In purple. Okay, we need to use that. So to solve this equation, I'm going to manipulate this equation to make it so that the left-hand side of that equation is exactly the same as the graph that I've already got drawn. So x squared minus 4x plus 2. Now I want to manipulate that equation. So what I'm going to do is I'm going to add x to both sides. And remember, when you do that to an equation, it doesn't change the solution. You're just manipulating it. So it's still going to have exactly the same solutions after I've done this manipulation. Okay, so that has now made the left-hand side look much more like this, but still not quite there. We need to subtract 1 from both sides. And that will give us, that's perfect, because 2 subtract 1 is 1, and this is x minus 1. And that's great. Okay, so now we have this drawn. That's already been drawn. So I need to then, in green, I'm going to draw this one. And where they meet, where they're equal to, will be the solution to this equation, which is the same as the solution to the one over here that I've manipulated into that one. So this is then what I need to draw, like so. So I'm going to go back up and draw that. So x minus 1 means it has a y-intercept at minus 1, and it has a gradient of 1. So for every 1 you go along, you go up 1. 1 along, up 1, 1 along, up 1, 1 along, up 1, 1 along, up 1. Okay, so we can draw that. Perfect. And then where they meet is going to be our solution. Now, it may not be perfectly correct because this is just a sketch, but we can get a pretty good indication. To me, that looks like 3.3, and this one here looks like 0.6. So that's what I'm going to go with. So I'm going to say that x equals 0.6, comma 3.3. Now we can also, if we have got a relatively fancy calculator, we could actually check this answer by actually solving that quadratic that we are trying to find the solutions to, like so. And the answers are 3.4, okay, and 0.6. Fine. So maybe I was a little bit out with this one, wasn't I? But don't worry, we can do a little bit of editing. We can put 3.4 there and draw a line a little bit skew with. There we go. There you go. That's 3.4. Yeah, it's fine. It's fine. That was my first answer. No one knows any different. Okay, let's change this up to 3.4. Anyway, there's always going to be a leniency. So even if you're one decimal place off, you're going to be absolutely fine. There we go. There's my two answers. Okay, a classic quadratic we need to solve here. And it says show clear algebraic working. So the first thing we're going to do is we're going to move all the terms to the left hand side because we want to have well, it equal to 0, and ideally we want the x squared to be positive. So we're going to add 9x to both sides, and we're going to subtract 7 from both sides, like so. So now a quadratic can always be written like this, which means that the a term is 5, just pairing it up, the b term is 9, and the c term is -7. So now we can use the quadratic formula, which is on our formula sheet. Okay, and it looks like this. So we can say that x is equal to -9 because it says minus b and b is 9. Plus minus the square root of b squared, so that's 9 squared. And then minus 4 lots of a, then lots of c. And that's all divided by 2 lots of a. Okay, great. So we can, what I'd like to do sometimes is to evaluate the bit underneath the square root, because I think that if you do get your answers wrong, this could give you an extra method mark. So that means it's -9 plus or minus the square root of 221 over, and then 2 times 5 is 10. Okay, so now I think we're good to work out what this is. So it's -8 plus root 221 over 10, which gives us 0. And what is that? 3 significant figures. So 5, 8, 7, or what we can then do is change that to a minus, and we get -2.3, and to 3 significant figures, that would be 9. Perfect. Okay, and then once again, if we've got you know, a somewhat fancy calculator, we can check that on the solver. So 5, 9, and -7. Yeah, cracking. There we go. That one and that one. Perfect. Quadratic inequalities, starting off with a linear inequality. So the first thing we're going to do is just multiply this out. So 4x minus 8 is less than 1 plus 8, 1 plus x. We'll subtract x from both sides, which gives us this. We'll then add 8 to both sides, and then we'll divide by 3 to get x is less than 3. Okay, hopefully not too tricky, that one. But now we've got this quadratic inequality, and what we're going to want to do is move all of the terms to one side, so it's equal to 0. So we're going to do 2x squared minus 7x minus 9 is less than or equal to 0, like so. Okay, and then we can, it says without using a calculator, so I'm probably going to want to factorize that. Now in order to factorize it, we can say that AC, which is the A term, which is 2, times by the C term, which is minus 9, is equal to minus 18, and the B term is equal to minus 7. Okay, now this is the way that I factorise quadratics. I know the A term is 2, so I write 2x all over 2. And that's because the A term is 2, so we've got 2, 2 and 2. Okay, now over here I need to find the two numbers that multiply to make minus 18 and add to make minus 7. Those two numbers are minus 9 and plus 2. And then you can see this bracket on the right has a factor of 2, so we can divide it by 2, and that will cancel out the 2 on the bottom. So it becomes 2x minus 9, then dividing through gives us x plus 1. Okay, great, that's factorised, which means that either 2x minus 9 equals 0 or x plus 1 equals 0 are our critical values. So solving this, adding 9 to both sides, then dividing by 2 gives us x is equal to 9 over 2 and x is equal to minus 1. So those are our critical values. So we haven't solved the inequality yet, we've just found the critical values. So if I just draw a quadratic, and we can see here that it's going to cut equal to 0 at minus 1 and 9 over 2. And then if I just draw that quadratic in like that, I'm looking for the part of the quadratic which is less than 0. So it gives values that are less than 0, so i.e. below the axes, and those are the values which are below the axes, and then the x values that give us that region are in between minus 1 and 9 over 2. So we say minus 1 is less than or equal to x, which is less than or equal to 9 over 2. And that's because it is just a single region. You can see there it's just a single region. If the question asks you to do greater than 0, then you'd have to look at the bits which are above the axes. So here and here, which means you'd get two separate regions, greater than 9 over 2 and less than minus 1. But it doesn't ask us for that here, so we've got one single region like that. Okay, and now it says, hence find the range of values for x which are both. So satisfy both of the two questions. So what x values are in between minus 1 and 9 over 2 and are less than 3? Well, 9 over 2, remember, is 4.5. So you have to be in between minus 1 and 4.5, but you also have to be less than 3. So that means you have to be in between minus 1 and 3. But you can't equal 3 because you need to satisfy this, and you're not allowed to equal 3 there. So this is the correct answer to that final combined inequality question, which I thought was quite a good question. Yes, circle theorems. Shout out to my friend Tom, who I was at school with. It always reminded me of him when I do circle theorems, because I used to really dislike circle theorems when I was doing GCSE. It was my least favourite topic, but it was his favourite. Anyhow, there are 8 circle theorems you have to remember. Check out my video on everything you need to memorise for IGCSE Maths, because there's a crib sheet there which has all the 8 circle theorems right there, ready for you to download in my Google Drive. Okay, well, this is a cracking question, this one, and it says, find the size of OCA. So straight off the bat, I'm going to want to draw a line connecting O and C, so that now I can see that the angle OCA is the angle that I get when I draw the lines O to C to A. So it's this angle in here. So that's what I'm looking for. So let's call that X. Okay. Now we've got a tangent here as well, which is going to be useful. And we've got a radius here. So tangent and radius meet at 90 degrees. So I know that this angle in here is going to be 90 minus 54. So I can say angle OBC is equal to 90 minus 54, which is equal to 36, as radius and tangent meet at 90 degrees. Because it does say give reasons for each state of your working, so you have to state the circle theorem that you are using. Let's put that on the diagram. Okay, lovely. Okay, fine. Next one, let's find this angle up here. Now that angle is 51. So I can say ACB is equal to 51 degrees. In fact, I can even do my calculation how I found that was to be 51, which was 102 divided by 2, which is equal to 51. And that is as angle at centre is double angle at circumference. And the way to spot that is this arrowhead situation that you've got going on. You've got that arrowhead, well then yeah, the angle there and there, the angle at the centre is double the angle at the circumference. Okay, now what I'm aiming at here is is to work out the angle in this arrowhead, because there's 4 angles in the arrowhead. I've got 2 already now, and if I find this one, that's going to help me find the overall angle which we're looking for. So the next one is this angle in here, and that is going to be angle AOB, the reflex angle. So reflex AOB is equal to 360 minus 102, which is 258, and that is the angles around a point add to 360. Okay, that was horrendous the way that I wrote that. Sorry, my writing is messy. Okay, so we now know that that's 258, so we can work out this angle in here, and that is, I think I'm doing this in the most efficient way, and that is 360 minus 51 minus 258 minus 36. So let's do this on the calculator. Okay, that's equal to 15. Okay, and that is because angles in a quadrilateral add to 360. Gosh. Okay, so now this question is a beast. Now if I draw that back in there, and that's the angle we're looking for, because these are both radii, we know that those 2 angles are the same because it's an isosceles triangle. So we can say the angle we're looking for, which is OCA, is equal to the angle CAO, which is 15, as angles in isosceles are equal. So 15 degrees. Okay, perfect. I really hope that was the most efficient way. If it wasn't, let me know in the comments, and very sorry. Maybe Tom will let me know. Okay, chord theorem. Now, a lot of people find chord theorems tricky, but what I always suggest is just make sure you write the formula out, and you make sure you include the intersection point for every distance that we're using. So on the first chord, which I'll highlight yellow, we would write that a to p multiplied by b to p. And that's going to equal, on the second chord, which I'll highlight in blue, again making sure that p is in all of them, it will be c to p multiplied by d to p. Perfect, so that is the formula. So we can substitute into that formula. So a to p is 8 and b to p is 4.5. C to p, don't know what that is, so we'll just keep it as c to p. And then multiplied by d to p is 3. Okay, great. So we can definitely solve for c to p here. And we can do 8 times 4.5 is 36. So 36 is equal to 3 lots of cp. So cp is equal to 36 divided by 3, which is 12. Okay, so that means that the diameter of this circle, because the blue chord passes through the centre, it means that CD is the diameter. So the diameter is CP plus DP, which is going to be 12 plus 3, which is 15. Now the circumference is equal to 2 pi r, as we know, or some people prefer pi d. And given that we know the diameter is 15, let's just go straight for that. So the answer is 15 pi, and we can do 15 pi on our calculator to get to 3 significant figures, 47.1, and that'll be centimeters. Perfect. Venn diagrams, and it says in a class of 30 students, you've got 15 have a black pen, 16 have a pencil, and 3 have no black pen or pencil. Tut tut tut. Make sure you come prepared for your lessons, please. So that goes on the outside because those people have neither, so they're in neither of the circles. Now let's look at the first circle here. That's all the people that have black pens, and that needs to add to 15. So what do I need to add to x to make 15? Well, it must be 15 minus x, because these two add to make 15 in total. And then the second circle, well, that needs to add to 16, so I put 16 minus x in here, because when it adds with the x, we get 16. Find the value of x. Well, if we add up each of the regions, it should give us the total number of students, which we're told was 30. So doing some cancelling, minus x and plus x, they cancel out. 15 plus 16 is 31, plus 3 is 34. So 34 minus x equals 30, which means that minus x equals minus 4 when we subtract 34 from both sides, times through by minus 1, so x equals 4. Now one of these 30 students is chosen at random. Write down the probability that this student has a black pen but does not have a pencil. So if you have a black pen but you do not have a pencil, then you are one of these people. And that's 15 minus x. So that's going to be 15 minus 4 over the total number of people. So that's 11 over 30, and that's going to be our final answer. Perfect. Okay, classic question this. You've got to make y the subject, and you've got y appearing on both sides. So first off, the right hand side is completely covered by this square root, so we're going to square both sides, and that's going to remove the square root from the right hand side, like so. The next step is to clear the denominator, so we're going to multiply the denominator up to the other side, and it's going to clear the denominator on the right hand side. We're then going to multiply out the brackets, like so, and then that gives us 3y plus 5. And then the key skill here is we want to bring all of the terms that include the y onto one side and all of the terms that don't onto the other side. I also want to reduce the negatives, so I'm going to move the y terms to the right hand side. It's not essential, you don't have to do that, but that's what I'm going to do. So I'm going to add this c squared y to both sides, and that's going to give me c squared y plus 3y plus 5, and then I'm going to minus the 5 from both sides, and that's going to give me this, and there we go, we've got the y's on one side and the non-y's on the other, and that allows us to factorize, so we can take a y out like so, which is perfect because then the final step is to divide by the factor, which was c squared plus 3. And that's equal to y, and that's it. That's job done. Now you may have got an equivalent answer, which I'll write down. If you have done it slightly differently, you may have had 5 minus 8c squared over minus c squared minus 3, and that would be completely correct as well, but just doesn't look as nice as my answer. Sorry. Okay, proof, and it says that we've got an expression here, and we need to prove that it's a multiple of 12 for all positive integers. Okay, great. So we're just going to multiply these out, and just being really careful with that negative in the middle. So we're going to multiply these brackets out, and because they're square brackets, we're going to write them like so. And then we're going to do 4n times 4n, which is 16n squared. 4n times 3 is 12n. 3 times 4n is 12n. And 3 times 3 is 9. And I'm just going to keep them in brackets like so. And then let's do the same over here. We're going to have 4n times 4n is 16n squared. 4n times minus 3 is minus 12n. And minus 3 times 4n is also minus 12n. And then minus 3 times minus 3 is plus 9. Okay, now if we want to remove the brackets now, we can do so. We can also collect up the n's here. We've got 24n. And we want to remove the brackets here, which means we need to apply this negative to every single term, not just the first one, every term. So it becomes minus 16n squared. When I collect these up, it becomes minus 24n, but we need to apply that negative, so it's plus 24n. And then here, plus 9, but we apply the negative, becomes minus 9. Okay, great. Now, we can cancel that out because you've got 16n squared and minus 16n squared. And plus 9 and minus 9, they can get cancelled as well. So we're just left with 24n and 24n, makes 48n. And then we can show nice and clearly that is a multiple of 12 by just simply factorising out a 12. So we get that. And then, good practice for A-level, always write a conclusion statement. You can say, hence, the expression is a multiple of 12. Perfect. Classic quadratic simultaneous equation here, and we have the quadratic equation on the top and the linear one on the bottom. Now we need to make either x or y the subject of the linear. I think the easiest thing to make is x the subject, because I don't want to be divided by 2 because I need to get 5 over 2 or 2.5. So it's just nice and easy to say x is equal to 5, and then we're going to subtract 2y from both sides. So the 2y disappears from the left side and becomes a minus 2y on the right. Now we can write out the quadratic equation, but instead of having an x squared here, we will say it's 5 minus 2y is x, and then squared. And that's going to equal 10 minus y squared. So we've just substituted x into the quadratic equation at the top, replacing the x here with a 5 minus 2y. Okay, now that 5 minus 2y is squared, so we can write it as a double bracket like this. And then we can do 5 times 5 is 25. 5 times minus 2y is minus 10y. Minus 2y times 5 is minus 10y. And then minus 2y times minus 2y is plus 4y squared. Like so. And then we can collect that up to make minus 20y. And then we can add y squared to both sides. So that will cancel the minus y squared on the right, and added to the 4y squared already gives us 5y squared. And we're going to have minus 20y as well. And we're going to have plus 25. But we're also going to subtract the 10 from the right hand side, so that becomes plus 15 equals 0. So we have added y squared and subtracted 10 from both sides. And whenever you're trying to solve a quadratic, you can hopefully, well, first off, we need to spot to see if there's any factors we can divide through by. And we can divide through by 5, and like so, and you're able to do that because it's equal to 0, this equation, and dividing 0 by 5 just gives you 0. Okay, we can factorise this, which is a relatively straightforward one, because you've got two numbers that times to make positive 3, add to make negative 4, they must be minus 1 and minus 3, which means that y equals 3 and y equals 1, like so. And then if we just scroll up slightly, you can see the x coordinates are 5 minus 2y. So for here, the x coordinate is 5 minus 2 lots of 1. And for this one, the x coordinate is 5 minus 2 lots of 3. So that's equal to 3, and that's equal to minus 1. And then I like to write my answers as coordinates, like so. So x and y, so you can see they're nicely paired up. Perfect. Okay, we've got two mathematically similar shapes, A and B, and we know the volume of each of them. So what we can do is we can work out the scale factor of in terms of volume. So the volume scale factor, I call it k cubed, because volume is third dimension, and the scale factor is the linear one-dimensional scale factor cubed. So I always take the larger one and then divide it by the smaller one, because that gives me the scale factor that takes you from the small one to the large one. Okay, so that's k cubed, that's the volume scale factor. So let's work out what that is. So we'll do 1125 divided by 576. Okay, that's great. That gives me a lot of confidence because those are both cube numbers. And that also gives me an idea that I will need to cube root those numbers to get the linear scale factor. So that's the scale factor we use to convert things like distances or heights or widths, and that's 5 over 4. But I'm not converting distances and widths. I need to work out, in fact, area. So area means I need to use k squared, because area is second dimension. So k squared, I take my k, which we've worked out was 5 over 4, and I square it, I get 25 over 16. Okay, great. So now I'm free to convert between areas. It's asking me to work out the surface area of the solid B, and that's also the smaller one, which is quite helpful. So I'm going to call that one x. That's going to represent the surface area of B. So if I'm converting between surface area, I need to multiply by k squared which is 25 over 16. So the surface area of this object will be 25 over 16 times by x. Okay, great. So now I've got the surface area of both shapes, so I can look at this bit of information here, which says the surface area of A, which is 25 over 16x, plus the surface area of B, which is just 1x, is equal to 3198. Okay, well, how many x's have I got here? Don't say 2, because I've got 1x here and I've got 25 over 16x's there. And 1x plus 25 over 16x gives me a total of 41 over 16x. And that's great. I can just divide through by that. So I can do 3198 divided by that previous answer. And that gives me what x is. And x is exactly what we're looking for, because that is the surface area of solid B. Perfect. Okay, graph transformations. I know students find this quite tricky. Now, what I'd always recommend to do is to start off by drawing the original sine graph on the grid. And sine starts at 0, 0, and then it goes up to 91, and then back to 180, 0, then 270 minus 1, and then 360, 0. Now, my technique for this one is to think first off of the range of the graph. So sine graph fluctuates between 1 and minus 1, which means it has like a range of 2. Whereas this graph goes to the maximum of 4 and then a minimum of minus 2. So that is a gap of 6. Okay, so what's the scale factor it's been stretched? Well, if the gap was 2 and now it's 6, it's been stretched by a factor of 3. And A is what stretches the graph in the y-axis. So A is equal to 6 divided by 2, which is equal to 3. Okay, great. Now I think about the midpoint of the range. So for the green, the midpoint between minus 1 and 1 is 0. So that is kind of like the like the median line, if you were. And for the new graph, the midpoint between 4 and minus 2 is 1. So whoops. So that is like the median line. Okay, and you can see that the new graph, the median line is shifted up by 1. Okay, so that means that the graph has been shifted up, and C does the shifting up or down. So C is equal to 1 because it's been shifted up by 1. Okay, and now we've done that. The last thing to do is the horizontal shift. And for this, we look at either the maximum or minimum. We can look here at the maximum. Okay, so the maximum point on the original graph is at 90, whereas here it's at, what's that, 45? So what we've had to do is we've had to shift the graph to the left by 45. Now, in order to shift it to the left, inside the bracket, we need to add on something to shift to the left, because it's always the opposite of what you think when you're working inside the bracket. So that tells us that B must equal 45, and that will give it a 45 shift to the left. Okay, so that's it. Yeah, all done. Okay, we have a sector of a circle, and it's asking us to calculate the area. So the formula, which you'll need to remember, of the area of a sector is the angle that the sector makes divided by 360, and that gives you the fraction of the overall circle, because 360 is the overall number of degrees, and the area of the whole circle would be just pi r squared. Okay. Oh, I've just said area, but I just haven't read here, arc as well. So the arc length is a fraction of the circumference, and the fraction is proportional to the angle that the sector makes again. So it's the angle out of the whole circle's angle, which is 360, times by the circumference, which is 2 pi r. Okay, so those are the two formulas that you need to remember. If you remember the area and the circumference of a circle, you just literally need to multiply by the fraction, which is always the angle divided by 360. So not too tricky to remember those ones. Okay, so let's start with the arc length because we have information on that and we know that it's 54. So we can put 54 into there. We know the angle is 75 times by 2 pi and then times by r as well. Okay, so from this we can work out r by just reversing this. So we can do 54 divided by 75 over 360, and we also need to divide by 2 pi as well, and that should leave r on its own on the right hand side. Great. Okay, so r is equal to 41.25 roughly, and now we can use that in the area formula. So area is equal to 75 over 360 multiplied by pi multiplied by 41.25 squared. Okay, so I'm just going to square this, keep it in my calculator. That gives me r squared, and then I'm going to times it by 75 over 360, and I'm going to times it by pi. And oops, that's not pi. That's pi. Easy as pie. 1113.8, but it says to two significant figures, so that would be 1100 centimeters squared. Okay, great. Volume of cones and spheres, and we have here a cone and a hemisphere. Perfect. And they are merged together to create this shape. And the key bit of information here is that the volume of the cone to the hemisphere is 3 to 4. Okay, also, because this is a hemisphere which has a diameter of 20, it means it has a radius of 10, which means from the center of the sphere down to the bottom is 10, which means that the height of the cone is going to be h minus 10, such that when you add them together you get h, because h is the height of the cone and the hemisphere added together. So I think that's going to be helpful, so I'm going to put that on the diagram over there, and then it's asking us to find h. Well, we have the radius of the hemisphere, so we can work out the volume of the hemisphere, because the volume of a hemisphere is equal to, well, the volume of a sphere is 4/3 pi r cubed, so a hemisphere is half of that, so rather than 4/3, we're going to half that to become 2/3. So we can say this is 2/3 pi, and the radius is 10. So this is going to give us, well, that's 1,000, so that's going to be 2,000 pi over 3. Okay, great. Now a little bit of a ratio here. The volume of the hemisphere is 4 parts. So 4 parts is equal to 2,000 pi over 3. So divide by 4, that gives us that 1 part is equal to 500 pi over 3. And we know the volume of the cone is 3 parts. So the volume of cone is equal to 3 parts, which is equal to 3 times this, which is just 500 pi. Great. Now we also know the volume of a cone. We know the formula for that is 1/3 pi r squared times by height. Now height, in this case, of that cone is h minus 10. So I'll write in here h minus 10, because I don't want to get confused by writing h for height, because the cone's height is actually, yeah, h minus 10. Okay, great. We can divide through both sides by pi, and we also know the radius of the cone is the same as the radius of the hemisphere, because they're attached, so that's going to be 10 squared, like so. Okay, so moving over here, we can times both sides by 3 to get rid of that third, like so. We can divide both sides by 10 squared, which is 100, so that gives us 15 is equal to h minus 10. And then finally we can add 10 to both sides, so we get 25 is equal to h. Perfect. And that is our final answer. Great. Okay, perpendicular lines, and we have a straight line L that is given as such. The point A has coordinates 0, 2, and the straight line M is perpendicular to L and passes through A. Okay, so let's start with L, and let's rewrite it so that Y is the subject. So I'm going to minus 3x to both sides, like so, and then I'm going to divide through by 2. So I get this. Now I've done that because that is now in the form y equals mx plus c, and that allows us to see nice and clearly what the gradient is of that line, because the gradient is the m. So I know the gradient of L is minus 3 over 2, and because m is perpendicular to L, m has a gradient which is the negative reciprocal, because they're perpendicular, which we can calculate by doing minus 1 divided by that gradient, or we can just think of it as flipping the fraction over and changing the sign. So that's the gradient of m. We also know m goes through the point 0, 2. So that means that because it goes through the y-axis at 2, because 0, 2 means it goes through the y-axis at 2, we know the y-intercept is 2. So we can just write the equation like that. Okay, rather than having to sub into y equals mx plus c, because we know that is actually the intercept, we can just say plus 2 like that. Okay, right, that's all that information done. Let's move down, and it says that line L crosses the y-axis at the point B. Okay, so the point B then must be the point 0, 17 over 2, because line L crosses the y-axis means that that's the y-intercept, and because we've got line L in this form here, you can see what the y-intercept is. It's 17 over 2, so there we go. B must be the point 0, 17 over 2. Line L and line M intersect at the point C. Okay, a bit trickier that one, but the point C then is where these two lines intersect, and if you want to find where two lines intersect, you can set them equal to each other. If they're both equal to y, you can set the other part of it equal to each other. So we can say this is equal to this, like that. And this is going to yield the x-coordinate of the intersection point. Now I've got denominators here, fractions. I know students in GCSE don't like fractions, so what we're going to do is we're going to multiply through by the common denominator. So we've got 2 and 3's, so we're going to multiply the equation through by 6. Okay, so that becomes minus 9x. This becomes 3 17s, as we know from darts. Triple 17 is 51, of course. This becomes 4x, and this becomes 12. That's much better. Much easier to solve an equation now without any fractions in. We can add 9x to both sides, and we can subtract 12 from both sides, and then we can divide through by 13 to get x is equal to 3. And it would also be quite useful, I suspect, to find the y-coordinate of C. So we can sub this x-coordinate back into either of the two lines. Perhaps this one's easier because you've got 2/3 of x. And if x is 3, 2/3 of 3 is 2, and then plus 2 gives us 4. So y is equal to 4. Okay, great. So that means that C obviously is the point 3, 4. Okay, now it says work out the area of triangle ABC. Okay, well we should have all the information now, but to make our lives even easier, let's draw a quick sketch. Okay, so let's just draw a quick grid and see what on earth is going on here. So we've got line L, it's got a negative gradient and an intercept of 17/2. So it's going to cross here at 17/2, and it's going to have a negative gradient, so it's going to come down like this somewhat, something like that. Whereas the other one is going to cross at 2, y-intercept of 2, and it's going to have a positive gradient. So it's going to look something like this. Again, really rough, but doesn't matter, it's just a little sketch to get an idea of what's going on. And we know they intersect there at the point 3, 4. And we need to work out the area of this triangle. Well, to work out an area of a triangle, really all we need is the base, which we can call that, and then the perpendicular height, which we can call that distance there. Okay, so the base is the gap between 17/2 and 2, which is equal to 13/2. And then the height is, that's where x equals 0, and then going along here, that's where x equals 3. So the height is 3 minus 0, which is equal to 3. So the area is equal to 1/2 times by the base times by the height. So 1 times 13 times 3 is 39, and on the bottom 2 times 2 is 4. So 39/4 is the correct answer, or you could write it as a decimal if you wanted to, or leave it as a fraction. Perfect. Okay, we've got functions, and we've been asked to work out the inverse function of g. So to do that, we set y equal to the function. We then swap the x's for the y's and the y's for the x's. So we get x equals root y plus 2/5. And then we need to make y the subject again. So we're going to times both sides by 5 to clear that denominator. We're going to subtract 2 from both sides. And then we're going to square both sides to get rid of the square root. And whatever you do, don't square them individually like that. When you square both sides of an equation, you have to square each side collectively, so that you're squaring the whole side. So we put it in brackets and then square and then that is going to cancel the square root on the right hand side. Now, that is it. That's the inverse function. Yep, so we just write it as f of g to the minus 1 of x is 5x minus 2 squared. Okay, great. Now we've got a composite function here where we're doing x goes into f and then that goes into g. So x into f, well that's just f of x, which is 3x plus 4. And then putting that into g means that we need to replace all the x's in g, which there's only one, with, or f of x's, which is 3x plus 4. So we write out g, but rather than writing x, we write 3x plus 4, because we're subbing in f of x in replace of x into the g function. And we get that over that, and then that's equal to 3. Great. So now we can, whoops, I didn't mean to do that. Yeah, we can solve. So first step is, as always, we'd want to clear the denominators. Let's multiply both sides by 5 to get 15 on the right and clear the denominator on the left. And then let's subtract that 2. Perfect. And now is the perfect time to square because we have isolated the square root term. So to remove the square root, we can square both sides of the equation. And that will just give us 3x plus 4 is equal to the square root of 13, which is 169. Sorry, the square of 13, which is 169. And then we can subtract 4 from both sides, like so. And that does divide by 3. It gives us 55. Perfect. So that is our final answer. Okay, kinematics. And we've got a particle moving along a straight line. And the displacement is given as this. So the first thing I'm going to do, because I know we're going to be differentiating, because kinematics is all about differentiating, I'm going to write s as t plus 4, and there's a t on the bottom there, so that's the same as a t having a negative power, and it's just t, so t to the 1, but because it's on the bottom it's a negative power, so it's t to the minus 1. Okay, now that allows us to work out the velocity, which is the derivative of the displacement, and that's going to be useful because it says the particle comes to rest. So rest is talking about the velocity of the particle being 0 if it's at rest. So we can differentiate with respect to t. So t differentiates to 1. And then to differentiate this term here, well, we use the standard rules of differentiation, which is take the power times it by the coefficient. So minus 1 times 4 is minus 4. And then write t. And then drop the power down by 1, so it becomes minus 2. And we want that to equal 0 because we want the velocity to be 0 because it says at rest. Let's add this 4t to the minus 2 to both sides. And then perhaps it's more easy to understand what's going on, how to solve this equation, if we write that minus 2 power of t as just t squared on the denominator. Because then we can multiply both sides by t squared to clear the denominator, like so. And then we can square root both sides, so we get t is equal to 4 plus or minus, but t has to be positive, so 2 is the only answer. Okay, great. And then next it says when t equals 8, p is at the point B. Find in meters the distance A to B. Okay, well, S tells us the displacement of the object. So let's sub in, let's find point B by subbing in t as 8 into the displacement formula, which is t plus 4 over t. So when S is 8, we get this, which is equal to 8.5. Okay, great. And then let's look at the point A, and we can sub in S is equal to 2 at the point A. So it becomes 2 plus 4 over 2, which is equal to 4. Okay, so at the point B, the object is 8.5 away from its start, and at the point A, the object is 4 away from the start. So the distance of AB must be the gap between them. So it's 8.5 minus 4, which is equal to 4.5. Perfect. Sequences. And we have that the sum of the first n terms of the arithmetic sequence is 570. The fourth term of S is 12. Okay, so that's useful. Now, the formula for the nth term is a(n), which is the term in the nth position, is equal to a, which is the first term, plus n minus 1d, where d is the common difference. So we can use that formula to write this information. So we can say that 12 is the term, and it's equal to the first term plus n minus 1. Well, n is the position of the term, and it's the fourth position, so n is 4, minus 1 is 3, and then times by d. And we can use exactly the same formula for the next bit of information. So 30 is the term, a plus n minus 1 will be 10 minus 1, which is 9, and then times by d. Now this is a simultaneous equation which we can solve straight away by subtraction, because the a's will cancel out. So 12 minus 30 is minus 18, and 3d minus 9d is minus 60. We can divide by minus 6 to get d is equal to 3. And then with any simultaneous equation, it would be useful to sub back in to one of the original equations and replace the d here with 3, because we know that d equals 3. So we get 12 is equal to a plus 9, so a is equal to 3. Okay, great. Now let's move over to the other side to work out the value of n, which we're going to need to use the bit of information at the top, because we've used these two. So the information at the top says that the sum of the first n terms, and we know the sum of the first n terms formula, which is on the front page of the formula sheet, and it's n over 2 is equal to 2a plus n minus 1d. So we're told that that's 570. Now we know a is equal to 3, and we know d is equal to 3 as well. Now what I like to do is multiply both sides by 2 here to cancel that divide by 2 on the right hand side. So that gives me 1140, and it gets rid of that divide by 2. 2 times 3 is 6, and then multiplying out this mini bracket, n times 3 is 3n, and minus 1 times 3 is minus 3. Okay, great. Now inside this square bracket we can simplify. There's 3n, and then there's 6 minus 3, which is just plus 3. Okay, great. Now we're going to multiply this bracket out to get 3n squared, because n times n is n squared, and then 3 times n just gives us 3n. This is a quadratic, so to solve it we need to set it equal to 0. So we need to move that 1140 over to the other side, and that will become a minus when doing so. Each of these terms can be divided by 3, so we're going to divide through by 3 to make it easier for us to factorise. Dividing that by 3 gives us 380. Perfect. Okay, so we need to show clear algebraic working, so we need to show the factors here. Now, to factorise this, I know that one must be positive, one must be negative, because they times to make a negative number. I also know that they add to make 1, because it's 1n here. So they must be very close together, because one's positive, one's negative, add them together to make 1. The numbers must be close together. So 400 is 20 squared. So the numbers must be pretty close to 20. In fact, be plus 20 and minus 19 will do the job, because they times together to make minus 380 and they add together to make 1. Perfect. So we get n equals minus 20 or n equals 19. Now we must reject the negative 1 because n is a position in the sequence, so you can't have a negative position. So n is equal to 19, which is good. It has to be a whole number, and positive, which 19 is. Fantastic. Final question, and it has to be, of course, vectors. The trickiest topic, I believe, in the IGCSE. And that's why over Easter I did a masterclass on 6 topics, and of course one of those topics was vectors. So if you're interested in all those resources that I used, and the recording of the session, and video solutions to 30 questions, 10 of which were vectors, then you can purchase that. Link in the description. Okay, let's get on with this vectors question. And we have lots of information, which is all on the diagram already. So all of this stuff is on the diagram, which is great, but this is not, and that says that the point D lies on OB. Okay, so I will draw a line connecting O and B, and I will put D on that line such that OD is 3/5 of OB. So if that's OB going from O to B, 3/5 along the way will be somewhere around about here. So that's where I'll put the coordinate of D. Okay, that's good. And now I can actually work out what these are, because I can work out OB, which is A plus 3B plus a half A. I'm going to use decimals for this particular question because I think it just suits it a little bit better. Okay, so that gives us 1.5A plus 3B. So that's helpful because now I know that OD is 3/5 of OB, which is equal to 3/5 of 1.5A plus 3B, which I know is 0.9A plus 1.8B. Okay, I could put that on the diagram, and in fact I will do, because I think that's useful. We also know what dB is now, of course, but I won't put that on the diagram just yet. I don't want it to get too crowded, but we could do if we need it. Okay, the question does ask for AD, so I'm going to draw that line on as well. So AD, like so, it's going to be along that line. So let's plot let's plot a route then, shall we, to get from A to D. Well, I can see that I can go down here and then up there. Perfect. I know both of those vectors, so that's all good. So that's AO plus OD, which is minus A, and then plus OD, which is 0.9A plus 1.8B. So that gives us a total of minus 0.1A plus 1.8B. Perfect. There we go. Great. That's AD. Okay. Let's put that on the diagram as well. So that's minus 0.1A plus 1.8B. Okay, and now the next part of the question says that the point E lies on CB such that CE is equal to KCB. Well, okay. And it says that given that ADE is a straight line, find the value of K. So that means that E must be here, because we have ADE, which is a straight line, and we also have E is on the straight line CB. Okay, now this is a vector cross question. So what I'm going to do is I'm going to notice that E really is the point which we're concerned about, because the question is asking us to find CE as a fraction of CB. So we need to know where E is. And also E is on two separate lines. It's on CB and it's on ADE, which is, again, means we're going to be using a vector cross method. So I'm going to draw a blue line, which is one of the lines that E is on, and I'm going to draw a yellow line, which is the other line that E is on. Okay, and then the method proceeds like this. I need to work out the yellow line, which is CB, which is, we go minus 2B plus A plus 3B plus a half A. So that's minus 2B plus A plus 3B plus 0.5A, which simplifies down to, how many A's we've got? We've got 1.5A, and we've got minus 2B plus 3B, so plus B. Okay, great. So that's the yellow line. And then to get to this magical place, point, E, then we need to say that CE is a fraction of that yellow line. And in fact, we are told that it is K lots of the yellow line. Because in the question it says that it is K lots of CB. Okay, great. So we've got to E using the yellow line. But we've got no idea where on the yellow line it is. So we need more information about the point E. And that extra information is the fact that it's on the blue line. So the blue line, well, we know A to D, and that means that we can work out A to E. Because A to E, going along the blue line, is actually an extension of AD. If we multiply AD by some value, I don't know what it is, but it's going to be more than 1, let's say it's like 1.5, then multiplying AD by 1.5 is going to give us AE. So a bit of a tricky question this, because most of the vector cross questions that I do, or I've done on my channel, or in my revision sessions, they're normally you just have to work out a fraction of a line, but this time it's an extension of a line. So AE is x times by the line AD, like so. Okay, great. Now we would love to be able to pair these up in order for us to move forward, but we can't yet because they're not actually the same vector. But what we can do is we can write CE using the blue line. Okay, so if I get my highlighter out and I'm on C and I want to use the blue line, I have to go minus 2b plus A and then an extension of AD, like that. So it's going to be minus 2b plus A plus that blue line, which is x minus 0.1a plus 1.8b. Ooh, what a tough question this one is. Okay, great. Now we have CE written by using the fact that it's on the yellow line and written using the fact that it's on the blue line. And that's 2 bits of information, so we can solve to work out the ratios, and we can collect the two, we can set the two equal to each other. So this one and this one. So I'm going to set them equal to each other, and I'm going to expand out as well at the same time. So 1.5 Ka plus plus Kb. Okay, that's me expanding out the top one. Is equal to, and then let's expand out the blue one, minus 2b plus A minus 0.1 xa plus 1.8 xb. Okay, now because they're the same vector, it means that their A's and their B's must be balanced. So if we look at the A's, there we have 1.5k on the left hand side. That's how many A's we have. And on the right hand side we have, in fact let's just highlight them so we can see nice and clearly. We've got 1.5k, we've got 1, and we've got minus 0.1x. So on the right hand side we've got 1 and minus 0.1x. Now let's look at the B's. We've got KB on the left, we've got minus 2b, and we've got 1.8xb on the right. So we can say that we have k on the left, and we have minus 2 and 1.8x on the right. Okay, great. Okay, so to solve these simultaneously, I can multiply the top line by 18, and that will line up the x's, which is great, so I can cancel the x's, which will give me k. Okay, so 1.5 times 18 is 27. So I can say 27k is equal to 18 and then minus 1.8x. And then on the line below I can keep that one exactly the same, because now the x's line up, they have different signs, so I can add them together to make them cancel. Adding the left hand side gives me 28k. We have 18 plus minus 2 is 16, and the x's cancel. Perfect. So k is equal to 16 over 28, which we can simplify down to 8 over 14 or 4 over 7 for our final answer. And that's it. That's the end of the paper. Really hope you enjoyed that and found it useful. And if you did, then I would recommend signing up to my live revision session that I'm going to be doing on Sunday the 31st of May, because I compiled 2 more of these predicted papers that are challenging, and they are focusing on those high value topics that didn't come up in paper 1. The session is 3 hours long, and I will be going through as many of the 60 questions as I possibly can, and any questions that I don't have time to complete I will create video solutions for, and you get full written solutions for all the questions and a recording of the session as well. Now, I've had fantastic feedback, not just from the last 2 years that I've run this, but also literally this year, because I've already done a session for paper 1, and that was great. Also, you'll get to vote for which questions that you would like to see, and you will get access to the resources literally straight away, so that you can get cracking on the questions yourself, and gives you a lot of time to prepare for the session, so that you know what questions to ask. And I'm very good at making sure that I answer all the questions, so that all the students are understanding of what I'm doing at that moment. And at the end of the session as well, there's a Q&A where you get to ask me any questions at all, and I try and give out as much exam tips as possible. Okay, yeah, so that's the session. If you sign up, fantastic. Either way, I wish you all the best for your IGCSE Paper 2. Do let me know how it goes, and yeah, bye for now.